Hi guys. I'm actually going to do a regular lesson about how to solve for a system of equation by using substitution. Now, you guys know what the word substitution is. Like, say that I gave you an equation and I said substitute x is equal to 5. What that means is wherever you see an x, you're going to plug in a 5, right? So, I'm going to actually start off with this example from IIS 2.1. You'll get another video on that tomorrow, but I know that I saw a bunch of people having difficulty. I'm actually just going to do the lesson on substitution, and you're going to be working on some practice questions today. All right, so you might want to actually copy this into your notebook as you go, and I'm going to give you 3 steps for this. To be able to do substitution, when you have the question, the first thing that you're going to do is solve one of the equations for a variable. Okay. Now, when I say a variable, it doesn't actually even matter which variable it is. And in this case, I think for step 1, what I'm going to do is, since c or s doesn't have a coefficient, let's say that I'm going to take that equation, c plus s is equal to 18, and solving for a variable means I want it to make it either look like c is equal to or s is equal to. I'm going to make it look like c is equal to. If I want that isolated, you're going to subtract s from both sides of the equation. Since they're not like terms with each other, c is equal to negative s plus 18. Right? So step 1 is complete. Solve one of the equations. I did the first equation for a variable. I solved for c right here. Okay? Second step. Substitute that variable into the other equation. So what we actually came up with is the fact that c and this whole entire thing, negative s plus 18, are the same exact thing. So I said the other equation. Originally in step 1, we used the first equation, so I'm going to use this equation. 10c plus 5s is equal to 125. Let me copy that down. But I want to substitute the variable into the other equation. Now, instead of the c, I want to plug in negative s plus 18. So instead of this c, I want to plug in negative s plus 18. So copy 10 instead of c, copy the plus sign, copy the 5s, copy everything. I'm also going to write down and solve for the remaining variable. Okay. So now that I did that, I actually can use pouches and coins. It's now only with one variable, so you should be able to solve for that. Use distributive property, so that'll be negative 10s plus 180 plus 5s is equal to 125. Okay. I have 2 variables here and here that I can combine like terms for, so that'll become negative 5s. Copy the 180 is equal to 125. Okay. Still solving for s, so I want to get this out of the way. So subtract 180, subtract 180 from both sides of the equation. Left with negative 5s is equal to 55, and that'll be a negative. Okay. Last step, to isolate the s, I want to get rid of that, which is a multiplication, so divide by negative 5 divide by negative 5 to make those cancel out, and get s is equal to positive 11. Okay, so I solve for the variable. Step 3. Now, keep in mind that you're looking for a point of intersection, a coordinate point. So in step 3, substitute excuse me, your answer Okay, so substitute your answer into one of the original equation. Now, I put it in parentheses. That's another conversation for later. But, okay, let me scroll up. I have two original equations. Either c plus s is equal to 18 or 10c plus 5s is equal to 125. I actually think this is the easier equation. So into this equation, c plus s is equal to 18. I'm going to substitute that answer that I just got. So c plus 11 is equal to 18. In other words, using pouches and coins. Okay, so now I have two things. Okay, since our original question was c plus s, I'm going to kind of think about this as like the x and the y. So your answer is 7, 11. Let's do another example question from your classwork today. Okay. I'm going to do 2 out of the 10 questions that I've assigned for you today. So let's start with question number 2, and I also want to do question number 7. Okay. So question number 2 from the worksheet says 2x minus 3y is equal to negative 1, and the other equation is y is equal to x minus 1. Now, the first step is to solve for one of the equations for the variable. Now, if you think about step 1, I can either solve for this x, I can solve for this y, or this x. Actually, this y is already solved for, so step 1 is already complete in this equation. So, step 2, substitute that variable into the other equation. I'm going to take this equation and plug it into that one. So, let me copy 2x minus 3y is equal to negative 1. But instead of this y, I'm going to substitute that whole entire thing. So 2x minus 3, parentheses, x minus 1 is equal to, copy the negative 1. Now I can continue to use pouches and coins to solve for this. Be careful when you're distributing this negative 3. This is going to end up being 2x minus 3x plus 3 is equal to negative 1. Combine like terms to negative x. Okay. Keeping in mind that you want to isolate the x variable, I'm going to subtract 3 first. And one last thing to get rid of the negative sign, either multiply, I'm going to divide by negative 1 on both sides of the equation to cancel that out, to say x is equal to 4. Okay. So step 2 is done. I solved for one of the variables. Now, step 3 is to take that answer and plug it back into one of the original equations. I can either plug it into this equation or the second equation, and to me the second equation looks easier. So let me copy the equation y is equal to x minus 1, okay, except it says to substitute that what your answer was from before. So y is equal to 4 minus 1, y is equal to 3. Now I got 2 points. My answer is 4, 3. Now, I'm actually not going to finish question number 7, but I'm going to get you started on it. Question number 7 is negative 4x plus y is equal to 6, and negative 5x minus y is equal to 21. Okay. So, let's look at step 1 for question number 2. Step 1 was to solve for one of the variables, and in this case the y was already solved for, so I didn't actually have to do anything for step 1. But looking at question number 7, I either need to solve for x, that y, that x, or that y. So you have 4 options. Out of the 4 options, though, I think this one with the positive y is going to be the easiest. So for step 1, when you're solving for a variable, I'm going to opt to use this first equation and to solve for one of the variables, move that out of the way. So step 1 is done. Step 2 is to substitute, instead of the y, that whole entire expression into the other equation. Now, since I already used the first equation, the second equation is negative 5x minus y is equal to 21. But instead of the y, I want to plug in what I just solved for. So, negative 5x minus, instead of the y, don't forget the parentheses, is equal to 21. So I basically copied the equation over, except I substituted that 4x plus 6 instead of the y. Now I have pouches and coins to solve. Because I have the parenthesis, the first thing that I'm going to do is make sure that I distribute that negative sign out to the parentheses to both inside terms. Combine like terms. Okay, so now pouches and coins. I'm kind of speeding through this part, but you guys have the option to pause and see what's happening there. Last thing to get rid of that negative 9, so divide by negative 9. Okay, so step 2 complete. I was able to solve for one of the variables. Right? So step 3, I want to take this answer and plug it into one of the equations. Now, it doesn't really matter which one of the original equations I want to do, so I think I'm going to use the first one. Negative 4x plus y is equal to 6. But in place of the x, I want to plug in a negative 3. So that's going to look like negative 4 times negative 3 plus y is equal to 6. I have to do a little bit of work, so that's a 12 plus a y. And last step from both sides of the equation. So my answer is negative 3, negative 6. Thanks.